All right, good morning. This is the beginning of our Ecology Are We Cool? Notes. And this was started officially in class on October 2nd. And of course, you need to put it in your table of contents based on whatever page number makes sense for you in your notebook. Additionally, if you weren't here for it, you need to make a pocket leading into this notes section. All right, let's begin. Our first opening slide has the title, of course, Are We Cool? Which is a reference to how we often have conflicts within our population. So you can see clearly that's happening. And usually when we have conflicts or some kind of interaction with others, we want to make sure we're getting along. So we ask ourselves that classic statement, are we cool? Next things up. In your notebook, connect density to your own comfort and survival. This is where you ask yourself, do I want to talk about how I feel about having more space to myself? Or do I want to talk about how I feel when I'm bunched up closely or in a high density situation with other people? So do you prefer to talk about low density or low population areas or high density and high population areas? In this example, you can think of the dots as people. So people are more spread out here, lower density population, or people are more tightly together here. This would be high density. This is East LA, and these are a bunch of apartments clustered together. Each apartment, of course, having people in it. So high density population are people living closely together. Here is the Verdugo Hills, so the hills just next to us in Burbank. And the homes are more spread out there, and they have a lot of open space. So that would be an example of low density or low kind of population density areas. What would you prefer to talk about? So here you would choose, right in this blank, you would choose to talk about high or low density in an effort to answer this question. It says connect density to your own comfort and survival. So you could put A, and then your choice, low or high density of people causes. And depending on what you chose, do you think it causes comfort or do you think it causes survival? And let's adjust this issues. So a low or high density of people causes comfort or survival issues because, and you're saying it causes comfort or survival issues because of one of these variables here. So these are different variables that affect your comfort or survival as a species. You see reproduction, space, conflict, community, and relationships. So choose one of those to support why you're comfortable or you think there's survival issues for a low or high density population. So the last part, this because here, the blank, is you talking about how one of these variables decides comfort or survival in a low or high population dense area. Good luck. Number 3 here is our problems for this chapter. We have 4 problems in this chapter that we want to potentially investigate or use to motivate our learning. And for population biology, or this section, Ecology Are We Cool? We have how can we know when our ecosystems have an environmental problem? That's our first problem. Second one is how does competition lead to stress? Second problem. Third problem, what increases the spread of disease? That's our third problem. And then how many people can the planet handle? And that's a human population question. So we are going to look at population issues for ecosystems and wildlife and nature, but also understand that as far as populations and how it affects humans and what humans should worry about with human populations. Overall, we're going to use these 4 problems to investigate and learn more about how scientists study populations and what populations mean, for the importance of kind of environmental health and also human health. All right, as usual, these problems are one of the first things we do. It's the beginning of us starting our investigations. It's what will guide us. And because it's going to guide us throughout this entire population biology section, we need to make sure we draw attention to it. So this is where you can write these in your notebook or on a piece of paper, but make sure you highlight them, you give them some kind of attention or drawing or artistic talent around it, just to make sure we remember what they are and we always have our eye drawn to it, because this is something we use throughout this whole Ecology Are We Cool section as we investigate a lot of important issues. Here we go. Next section is slide 4. So slide 4 here has a YouTube video, no sound. All you really need to do is look at the date here. This is 1885. These specks are an indication of population, and you're going to see a change. The more it changes, the more it's either more individuals or less. So if you see shrinking space, that means the population's reducing in size, reducing in population density, and if you see an increase of this pattern, it means an increasing population. This is for Los Angeles, starting in the 1800s. Let's watch. So, as we've seen from the 1800s to 2000, we saw an expansion of population for the LA area. Not surprising, we know LA is busy now, but you can see historically how populations have grown over the years. This next task asks us to, in our journal, turn to scientific strategies on page 37 to help with the task below. So it says review scenario. So we already reviewed, we investigated the video, which shows population growth, right? It says step 1, problem 1. So step 1 in our scientific strategies on page 37 asks us, what is the problem? So our task here is we have to try to design a scientific problem. So on page 37, everybody has this glued in, and this is the scientific strategies. Again, that's found on page 37. And step 1 is, what do we need to know? So we just examine the population growth in LA historically. The step 1 of any great discovery or problem-solving activity always starts with a problem. That's why we use it every time we investigate a new section of biology. Determine the problem, or a problem. So our first task, our step 1 task, using the scientific strategies on page 37 is coming up with a problem. This means that based on what you've seen, based on you seeing population growing in this LA area from 1877 to 2000, what's a question you would ask yourself based on that pattern? Based on the population growth from 1877 to 2000, what's a question you could ask yourself that you think is interesting to you based on that population growth? Or what's a question you could ask that you think is important for biologists or scientists or our society here based on the population growth? What's something you could ask yourself that you think is important for others or interesting to yourself that would be worthy of learning more? That's your scientific problem. Remember, when you write a scientific problem, it should be in the form of a question. So it needs to be something you're asking, a question you're asking, and that is your scientific problem. All right. It says step 2. It says use info or observations from video to develop a first draft hypothesis for the impact of the situation on the trophic pyramid. So step 2 is to create a hypothesis. Our hypothesis is an effort to explain a scientific problem. So if we're going to explain a scientific problem, for this one, we would look at the trophic levels. And humans are either at a primary or secondary consumer level, and you have to ask yourself, with population growth continuing into 2000 and now currently still growing, if our populations are still growing, what would you predict or hypothesize would be the impact if we have an increased number of secondary consumers on our trophic pyramid of the Los Angeles area? So think about all the producers, all the fruits and vegetables we eat or that grow in here, or that grow in nature, all the herbivores or plant eaters that exist in the LA area, and all of us and all the wildlife at the secondary consumer level. Based on our continued growth as humans in population, what would you predict is the impact on this trophic pyramid? What would the effect of us and an increasing population have on, and you make this prediction, you hypothesize. Remember, it's supposed to be confident. What do you think will happen? My hypothesis is if we have continued population growth at the secondary consumer level and regular or slower population growth with the rest of these levels. You can talk about energy flow. You can talk about any issue you think that secondary consumers and a high human population will place on primary or producers. Using the concepts of energy would probably be helpful, given we've studied it before. All right, step 3, it says, what questions or information should be asked to help learn more about the problem? And that ties back to we have our initial hypothesis that you just generated, and then it is seeking evidence. So what's remaining work to help build a greater knowledge of the current information and data? So we're just following along. We did step 1, step 2, and now step 3 is just trying to find more evidence to learn more about this problem. So based on the problem you've designed and the hypothesis you confidently predicted or said would happen, step 3 just asks you to ask, what kind of information would be helpful if you wanted to find out information about your problem or about your hypothesis? What are questions you could ask that would guide you or help you better understand the problem or better understand whether your hypothesis could be supported or not? What kind of information could support your hypothesis or make it, more understood, or would help guide you to finding out? What kind of information might help you start learning about whether your hypothesis has support or would be rejected? What information do you need? Either to better understand the problem, to understand if your hypothesis should be supported or not. What are questions or information you need to better understand the situation? All right, good luck. Slide 5. We'll continue that for video number 2 on our notes, all right? So good luck getting slides 1 through 4 done, and slide video number 2, we'll focus on 5 and the rest. Have a great day.